Hello, everybody. I'm here today to talk about high tension cable median guardrail. I'll be talking about um, the design side of it, and Emily will be talking more about the installation side of it. So years ago, when traveling through Minnesota, I'm sure all of us engineering folk quickly noticed this new cable guardrail in the median of the interstates. Back then, I know I thought to myself, wow, that is a lot of money in the ditch. I wonder how effective it is. So what studies have been done? In May, let's see, make sure it gets over there. In May 2018, Iowa completed an in-service performance evaluation of median cable barriers. There was an in-depth study of all the crashes before and after the installation of high-tension cable guardrail in Iowa. A total of 251 miles of median cable barrier systems have been installed along the interstates there. In a 9-year period, from 2007 to 2015, they recorded 6,718 median-related crashes. They found that when looking at median-related crashes, that fatalities were reduced by about 62%. Incapacitating injuries were reduced by about 31%, and non-incapacitating injuries were reduced by about 26%. They also found that the number of possible injuries increased by 11%, and possible injuries are reports of no visible injury but complaints of pain. And the amount of property damage increased by 108%. Well, this makes sense. High tension median cable barrier is an obstruction that is installed near the roadway. The guardrail's proximity to the roadway will increase the likelihood of a crash, but it also reduces the severity of the crashes. In a nutshell, nuisance hits go up, but severity goes down. NCHRP Report 711 was released in 2012. This report lays out recommended guidance to determine selection, use, and maintenance of cable barrier systems. First, we'll look at the inslopes. The guardrail should not be placed on slopes steeper than 4:1 unless it's been crash tested for that specific application. So flatter than 4:1 is what we're looking for, and 6:1 or shallower sloped medians or roadsides are preferred. Next, we'll look at the lateral offset. High tension median cable barriers should not be placed smack dab in the bottom of the ditch. Not only would we have to deal with drainage issues, but vehicles could potentially underride the guardrail installation. When the inslopes are steeper, as in South Dakota, overrides can occur if the guardrail is placed between 4 and 20 feet from the top of the inslope. Having the guardrail too close to the roadway can increase the likelihood of opposing traffic crashes causing deflection into the adjacent lanes of traffic. Then we get into the horizontal curves. The guidelines recommend that the installation should be located on the median side, farthest away from the outside of the curve. This is one reason why we see the high tension cable barrier move from one side of the ditch to the other. This allows more space between the barrier for added deflection, and it will also reduce the number of nuisance cable barrier hits. Lastly, we look at vertical curves. Here we deal with end anchors more than anything. End anchors should be placed as close as possible to the bottom and top points of the vertical curvature. End anchors should also be placed at points where there's a sudden change in vertical slope. So what do other states do? At the time we did our research, these were some of the guidelines that were in place. Wisconsin used test level 3 or test level 4 NCHRP 350 equipment at a max post spacing of 15 feet. Ohio used NCHRP 350 equipment and installed them 12 feet from the edge of the travelway. Montana used test level 3 NCHRP 350 equipment on 6:1 or flatter slopes. They used socketed line posts with a max post spacing of 16.5 feet. They're installing them 8 feet from the bottom of a V ditch and designing them with a maximum deflection of 10 feet. South Dakota has used test level 3 NCHRP 350 and MASH equipment. They're using steel socketed line posts with soil plates with a max post spacing of 16 feet, and they're installing them 5 feet minimum depth for the footing and are designing them with a maximum deflection of 8 feet. And Minnesota has used test level 3 and test level 4 NCHRP 350 and MASH equipment as well. They're using steel line post socket foundations with soil plates and are utilizing 4 pre-stretched cables with a maximum post spacing of 10 feet. They're installing them at least 8 feet above the inslope or ditch bottom intersection point and have an approved manufacturer's list. A majority of their inslopes are 4-to-1, which requires the cables to be installed 4 feet from the slope break. This is why we see Minnesota cables so close to the roadway. So what do we use? We are using the test level 3 MASH for length of need on main runs and test level 3 MASH for the end terminals. We've decided on a 4 cable system. And why is that? If you notice, the 3 orange lines on the left indicate a 3 cable system, and the 4 orange lines on the right indicate a 4 cable system. The blue lines are the override cases. The green lines are the underride cases. As you see here on the bottom in red, on the 3 cable system, it allows much more instances where the barrier may miss some of the vehicles. The 4 cable system is likely to capture all of the vehicles. What equipment do we use? Well, we use a driven steel socket with a soil plate. Minnesota tried to use a concrete foundation around the line posts, but found that the foundations tended to crack. We use 10-foot post spacing and designed for a 10-foot maximum deflection distance. The majority of our interstate system is designed with 6-to-1 medians. This allows for a greater lateral offset. We install the high tension cable barrier system at least 8 feet above the inslope ditch bottom intersection point, and our target offset is 14 feet from the edge of the shoulder. The concrete anchors for the end terminals are expensive, so we have a minimum length of 1,000 feet, but typically shoot for a 1,500 foot at a minimum. Our target maximum length is 1 mile, but we will go longer in some instances. We follow the NCHRP report 711 and place the high tension cable guardrail system on the median side, closest to the inside of the horizontal curves. And when running up to bridge ends, we want the end of the cable guardrail to anchor behind the bridge's guardrail. So we place it on the side opposite of the approach guardrail to the bridge. Another thing we looked at is the effect of snow. Based on recommendations from Minnesota DOT for snow drifting and snow removal, when possible on I-94, we place the guardrail on the side closest to the south roadway, and on I-29, we place it on the side closest to the east roadway. Currently, we have high tension cable guardrail installed along the interstate through Bismarck, Fargo, and Grand Forks, and we're considering additional high tension cable guardrail in other locations throughout the state. A few things we talked about after this presentation was put together. We found that existing typical sections from old plans are not always matching up to new survey information. So expecting a 6-to-1 slope and surveying a 4-to-1 slope changes the process, and we may look into flattening the slopes. Lastly, price-wise, a recent estimate for high tension cable guardrail, that's at $215,000 per mile. And that's what I got. Thank you.